Greetings of the day. So, first of all, I would like to introduce myself. I am Dr. N. Reddeppa. I have done my PhD Sri Venkateswara University, Tirupati. After that, I went to postdoctoral research fellow in abroad, People's Republic of China. So, after completion of postdoctoral fellow, then I moved to research scientist South Korea. So after completion of this one, then I have joined in our MITS institute. So let me thanks to I would like to convey my gratitude to our to be a assistant professor in MITS institute. So today the topic is wave optics. Today I give lecture on wave optics. So actually, there are two kinds of optics are there. The first one is ray optics. This is the ray optics, and the second one is wave optics. Wave optics. So here, what is ray optics? Ray optics refers to the optical systems. Optical systems. It was proposed by Newton. So according to Newton corpuscular theory, then second one is wave optics. Wave optics refers to the nature of light. Nature of light. So here, what is the light? So light means here whenever the light incident on our eye, then only we can see the objects. Otherwise, we cannot see objects also. So that's why here wave optics refers to the optical nature of light. It was proposed by Huygens. The wave optics proposed by Huygens. So there are three kinds of waves are there. There are three kinds of waves are. So first of all, what is wave? We should know what is wave. Wave means the disturbance of the matter. The disturbance of the matter is called wave. For example, here waves are produced. Waves are produced in solids, liquids, and gases also. So whenever just put a stone on the surface of the water, then waves are generated. Number of waves are generated. So this is the here in case of solids. So in case of liquids, so in case of solids, if you take a one string, then what will happen? One end is fixed to the other clamp, and another end just wave the thread. Then what will happen? So wave is produced. Wave is produced. It is nothing but the wave is produced because of disturbance of the string. Disturbance of the string. So in case of water also, whenever we disturb the surface of the water, then only waves are generated. So here the waves are transmission from one place to another place without the transferring the material. Without transferring the material. So that means the energy is transferred from one place to another place here. So in case of a wave means here the disturbance of the matter is called a wave. So how the waves are transmission? So the waves are transmission from the one place to another place without transferring the matter. So there are three kinds of waves are there. So wave optics again classified into three kinds. So these are mechanical waves. These are mechanical waves, and second one is electromagnetic waves. Electromagnetic waves. Electromagnetic waves. Third one is here matter waves. Matter waves. These are three kinds of waves. Then we have to see what is mechanical waves. What is mechanical waves? What are the types of mechanical waves? Here mechanical waves are two types. So here longitudinal waves, and next one is transverse wave. Transverse wave. These are the two types of mechanical waves. So now we have to see what is a longitudinal wave and how we can define the longitudinal wave. What are the examples for a longitudinal wave? Similarly, then what is the transverse wave and what are the examples for a transverse wave? Here, longitudinal waves. Longitudinal waves means here the wave. That means here the wave transferring from one place to another place parallel to the direction of the wave propagation. Parallel to the direction. So the vibration of the particles here. So it is parallel to the direction of the wave propagation is called a longitudinal wave. Is called a longitudinal wave. So the vibration of the particles, what will happen here? The vibration of the particles here transmit parallel to the direction of the wave propagation. Then it is called longitudinal waves. So the example is longitudinal waves. Example is sound waves. These are the examples is sound waves. So the longitudinal waves transmission like this. You see here, these are the. So these are called compressions and rarefactions. So this is the compression and this is the rarefaction and this is the compression. This is the rarefaction. So that means here in case of compression, here we can see the density of the particles or the density of the particles is more in this case. That's then only it is called compressions. Here we can see here. Then what will happen? The particles are far away compared to this one. The particles are, that means the density of the particles is very less. So then it is called rarefactions. Here compressions and rarefactions. So in case of sound waves, the particles are vibrate like this. Compressions, rarefactions. So compressions, rarefactions. So then we go for transverse waves. So what is transverse? So vibration of the particles, these are perpendicular to the direction of the wave propagation. Perpendicular to the direction of the wave propagation. Then it is called transverse waves. So here example is here. Example is here. The wave in the string. The wave in the string is called transverse wave. Is called transverse wave. So here transverse wave transmission, here the vibration of the particles vibration is perpendicular to the direction of the wave propagation. Then it is called transverse wave. So example is waves in the string. For example, you can see this is the. So this is the transverse wave. So in transverse wave, we can see this is the crest and this is the trough and this is the crest and this is the trough. Crest, trough. These are formed. These are formed. We can see crest and trough. Crest and trough. So here. So then it is called here transverse wave. These are called mechanical waves. These are called mechanical waves. Then we go for electromagnetic waves. So electromagnetic waves is also called non-mechanical waves. Non-mechanical waves. So for waves, especially for mechanical waves, the medium is required. The medium is required to transmission for the propagation of the wave. For the propagation of wave for mechanical waves. So in case of electromagnetic waves, medium is not required transmission the wave propagation. So that is most important. That is why it is called non-mechanical waves. That is why it is called non-mechanical waves. So your medium is not required. That means here electromagnetic waves transmission through the vacuum. That means without media, these waves are transferred. So the examples is here light waves. Light waves are example for electromagnetic waves. Then coming to the matter waves. Matter waves has the dual nature. Dual nature. So here particle as well as uh, wave nature. Particle as well as wave. These are called matter waves. So matter waves is also called de Broglie. So this kind of waves we can observe in the de Broglie waves. De Broglie waves. So this is the related to matter waves. Then in this one we can see what are the what is meant by wavelength. Here we can see what is the wavelength. What is wavelength? So wavelength means here the distance between two consecutive troughs. Two consecutive troughs. For example, this is the crests or troughs. So from here to here we can say this is the wavelength, lambda. This is called here lambda. The distance between two consecutive crests or the distance between two consecutive troughs is called wavelength. So the wavelength is represented with lambda. The lambda is represented with the lambda. So it is measured in angstrom units as well as centimeters and meters also. Next one we can see what is the amplitude. What is amplitude? Here amplitude means the disturbance of the particle. The disturbance of the particle is called amplitude. So in this case we can see this is the amplitude. So here this is the amplitude and this is the amplitude. Here we can see this is the amplitude. So amplitude means here the disturbance of the particle in a wave is called amplitude. It is represented with capital A, amplitude A. And the next one is frequency. Frequency. So how can you define the frequency? Frequency means the number of vibrations per second. The number of vibrations per second is called frequency. So it is represented with nu. It is represented with nu. So the unit is hertz. The unit is hertz. Next one is time period. What is time period? So time period means the time taken for one complete oscillation. The time taken for one complete vibration is called time period. So it is represented with T and the unit is seconds. The unit is seconds. So these are related to wave optics. So here in this topic we have to observe the what is wave here, what is wave, what are the types of waves. What are the types of wave? Actually, ray optics, wave optics, and wave optics again classified into three categories: mechanical waves, electromagnetic waves, and matter waves. So again, mechanical waves classified into two categories: longitudinal waves, transverse waves. So then how we can define the longitudinal wave? Here, longitudinal wave can be defined as the direction, the vibration of the particle perpendicular, parallel to the direction of the wave propagation is called longitudinal wave. So in this case, again we have to define the what is wavelength, what is amplitude, what is frequency, what is time period. Next we will go for interference. Next we will go for interference. So interference. So what is interference? Interference means the modification of intensity is called interference, or superposition of two waves here. Superposition of two waves. Superposition of two waves is called interference. Superposition means, for example, this is one wave is there and another wave coming like this. These are mixed to at a point. So these waves are mixed at a point. So then it is called, this is the superposition of two. So this is S1 and this is the S2, two waves. These two waves are coincide with at a point. Then it is called superposition of two waves. Then it is called interference. So one more definition we can say like this: modification of intensity is called interference. The modification of intensity is called interference because S1 wave wave is intensity is different and S2 wave intensity is different. So two different waves. So that's why here modification of intensity is also called interference. So then interference can be classified into two types. Two types. The first one is constructive interference. Constructive interference. Second one is destructive interference. Destructive interference. So then what is constructive interference? So the phenomena of formation of maximum intensity is called constructive interference. The formation of the phenomena of formation of maximum intensity is called constructive interference. Then constructive interference, how it will be formed? Constructive interference, for example, so this is the bird. Then we can see, we'll get this like this is the constructive interference. Sometimes we are getting like this, these are the opposite waves. Then we are getting here. So in this case we are getting like this. So this is the constructive interference. So here two waves are same direction. These are the same direction. Then we will get the, this is the superposition of two waves. We are getting this. This is the constructive interference. Similarly, here we'll see these are opposite direction. One is in this direction and one is downward direction and another wave is upwards direction. So superposition of these two waves, we are getting this kind of the resultant of a resultant intensity. This is called constructive interference. Constructive interference. Then what is the condition for the constructive interference? So for constructive interference, condition is here n lambda, where n equal to here n equal to 0, 1, 2, 3 like this. So this is the constructive, the condition for constructive interference. So this is the path difference between the two waves n lambda. Then we go for destructive interference. What is destructive interference? So the phenomena of formation of minimum intensity is called destructive interference. So we will get the intensity is minimum in this case. The intensity is minimum. Then it is called destructive interference. Then what is the condition for destructive interference and what? Then what is the example? We can say destructive interference like this. Then we will get the like this one. So sometimes here this kind of the result is this one. This is the destructive interference. This is the destructive interference. Destructive interference. Then what is the condition for destructive interference? Destructive interference. Here 2n plus 1 into lambda by 2. This is the condition for destructive interference. So in this case n equal to 0, 1, 2, 3, 4 like this. So these are the condition for destructive interference. Then what are the conditions for the interference phenomena? What are the conditions to get the interference phenomena? Conditions to get interference phenomena. Interference phenomena. So the first one is the light source must be monochromatic. The light source must be monochromatic and light source must be narrow. Light source must be narrow and light source must be coherent. The two waves must be coherent. Here the slits between the distance between two slits is small. That is small. And fifth one, the distance between screen and slit is large. So these are the conditions to get the interference phenomena. Then now just I draw the graph very clearly. You can see very clearly. And this is the light source. This is the light source and this is the slit and this is the screen. This is the screen and this is the slit and this is the light. You can see light. This is the slit. S1 and one more S2 is slit is there. So this is the S1 and this is the S2. So light source must be traveling like this. One source here and one more source here. Then what will happen? It traveling like this. So this must be small here. The facility S1 between S1 and S2 small, and this is the large. The distance between screen and this one large. This is the light source, light source. Then we can see, so the light source must be here monochromatic. If you need here interference, these are the conditions to get the interference phenomena. The light source must be monochromatic. Mono means single here. Mono means here single. So this is the single color. Monochromatic. The light source must be single color because white light has the 7 colors WebJR: violet, indigo, blue, green, yellow, orange, like this and one. So white light has the 7 colors. Here monochromatic means only single color because it has the only one wavelength. So the light source must be narrow. So this must be here narrow. And one more thing is the light source must be coherent here. Coherence. And the distance between two slits here S1 and S2. Here S1 S2 it is the small. And the distance between the screen and slit is a large. And one more thing is here this is the dark. This is the dark. So in this case only we will get the interference phenomena. In this case only we will get the interference phenomena. Then we can see what is next coherence here. Coherence. What is coherence? Coherence means the light source must be having the same wavelength and same amplitude, same amplitude, same amplitude, and same frequency, same frequency. And one more thing is it has the same phase, has the same phase. It is represented with the phi. So the two light sources, so S1 and S2, the two light sources must be same wavelength and same amplitude, same frequency and same phase. Then only it is called coherence. So the two light sources, it is called coherence. So in this case only we will get the interference phenomena. These are the conditions to get the interference phenomena. So next one is here the interference in thin films by reflection. So today we will discuss about the wave optics. So actually there are two kinds of optics is there. One is ray optics, second one is wave optics. What is ray optics? Ray optics means it refers to the optical system. It refers to the only optical. So it was proposed by Newton's corpuscular theory. Newton corpuscular theory. Next one is wave optics. Wave optics refers to the nature of light. Nature of light. So it was proposed by Huygens. It was proposed by Huygens. So here in this topic there are three kinds of waves are there. Here mechanical waves, non-mechanical waves, and matter waves. So again mechanical waves are classified into here two categories. One is longitudinal wave and the second one is transverse wave. Here wave means here the disturbance of the matter. The disturbance of the matter is called a wave. So waves are produced in solids, liquids, and gases also. So especially for mechanical waves, for transmission of mechanical waves, medium is required. Medium is required. So that's why it is called mechanical waves. So in case of electromagnetic waves, medium is not required. Medium is not required to transmission this kind of waves. It is called electromagnetic waves. So then longitudinal waves. So here actually in the case of waves, the particles are vibrate from one place to another place. Whenever you disturbance the matter, then what will happen? Here all particles are moving from one place to another place, from one point to another point. Transfer of energy from one place to another place without transferring the material, without the transferring the material is called here wave అనమాట. So in case of longitudinal waves, the particles vibrate. The particles vibrate here parallel to the direction of the wave propagation. Parallel to the direction of wave propagation. Then it is called longitudinal waves. So the example is sound waves. The example is here sound waves. So in case of sound waves, what will happen here? Compressions, rarefactions. So compressions, rarefactions are formed. So compression, in case of compressions, so the density of the particles is very high. So in case of compressions, in case of rarefactions, the density of the particle is less than 1. So here the distance between two compressions or the distance between two rarefactions is called wavelength. In this case, we can say like this. So the compressions of compressions of rare compressions is called wavelength. Then we go for a transverse wave. So in case of transverse wave, the vibration of the particles here vibrate perpendicular to the direction of the wave propagation. Perpendicular to the direction of the wave propagation. Then it is called transverse wave. Not. In case of a transverse wave, here the transmission is like this. This is the transverse wave. So we can produce the transverse wave in the string and what. The waves are produced in the string and what. Then what will happen? Then make a one string clamp to the other end, and another end just to make a hand. Then what will happen? It may vibrate the string and what. In this case, we can see here we can see crest and troughs are formed and what. This is the crest trough. Crest troughs are formed and what. Then we can see the distance between two crests or the distance between two troughs is called wavelength. The distance between two crests, two troughs is called wavelength here. Then in this case, we can define what is the amplitude. Amplitude means the maximum displacement. Maximum displacement of the particle is called here amplitude. For example, this is the amplitude. For example, this is the amplitude. We can see. So these are the amplitudes. These are the amplitudes. These are the amplitudes. We can so very clearly amplitude. So the maximum displacement of the particle is called amplitude. Amplitude. Then frequency. So frequency can be defined as the number of vibrations per second. So how many vibrations are how many oscillations are produced for one particle? Then it is called frequency. So frequency is represented with nu. So the unit is hertz. So for frequency, the unit is hertz. So here the example for transverse wave is the string wave, the waves in the string. The waves in the string. Then time period. What is time period? The time taken for one complete oscillation. The time taken for one complete oscillation is called time period. Then we go for interference. What is interference? So interference means superposition of two waves. That means two waves are merged together. Two waves are merged together. So then it is called for example. So this is the one wave and this is another wave. So these two are merged together at a point A. These are the two waves like this. This is the A and this is the B. This is the B and C. B and C. So these two waves are superposition at point A. So that is why it is called superposition of two waves. Then it is called interference phenomena. So what are the conditions to get the interference phenomena? So for interference phenomena, these are the conditions. Monochromatic and the light source must be monochromatic. The light source must be narrow. The light source must be coherent. The distance between two slits is small. At the same time, the distance between a slit and a screen is large. So in this condition only, we will see the interference phenomena. Interference phenomena. Then monochromatic means only having the single wavelength, single color, single wavelength. Narrow is means here we can see S1 and S2. The light source must be here narrow. Then coherence. Coherence means the light waves have the same wavelength and same frequency, same amplitude, and same phase. Same phase. Then it is called coherence. Same phase means at a particular time. At a particular time, the position of the particle along the wave. Along the wave is called the phase. The phase is represented with phi. The face is represented with a 5. Then the distance between two slits is very small, and the distance between screen and slit is large. So these are the conditions to get the interference phenomenon. And connectivity, this was next one is interference in thin films by reflection. Interference in thin films by reflection. At the same time, second topic is Newton rings. In case of Newton rings, we can see interference phenomenon. Interference phenomenon. Thank you very much.